Hey everybody, welcome back to the channel. This is The Art of Building and I'm Swa. So I'm going to bring you up to speed on the progress so far in this hydraulic lift cart. This is the frame mainly comprised of 3" by 3" 1/4" steel angle. The ends are 3" by 2". That's just basically because it's what I had. I've been putting together the scissor mechanism for the legs that are going to raise and lower the table. The next parts that are going to happen are we're going to have to mount the legs, which involves the legs have a roller at the end. This is off of a caster. The reason that I've welded this frame the way I did, instead of doing a miter and having a weld, if this wheel has to go all the way to the end, that weld could be in the way. So I opted for making a square notch. That way this flat is free and clear the whole way through. This frame right now is sitting about 2 inches off the table. That's how much it would sit off of the floor if I put these legs on. I'm aiming for using a steel angle 1/4" that will attach to the outside, weld it on. It'll hang down 2 inches. That means that it won't be too low for the casters on the cart. These will go around the corners of the cart, so that when this sits down on it, it'll be locked in place even though it won't be attached. This is the first iteration of the scissor mechanism for the leg. And I'll show you the other one because this one's got both casters on it. It'll sit in here like this. It's going to operate by raising, whoops, and lowering and running on that lower track. The top is going to be made of, this is 2" by 2" 1/8" angle. This is going to sit on top of the rollers and attached to the pivot point on this leg. There'll be a picture frame of this steel. And to fill in the hole in the middle, I'm planning on taking some smaller 90, recessing it, and welding it right here. That way I can set some plywood in between. It may be plywood with metal on one side, so I could either have a wood top or a metal top. But the next step is to attach these. First, I have to find the pivot point. I know that this can go back and forth a little bit. I have about 3/8 of an inch of play in here. So if I shift it 3/16 from one end, I have the same gap on each end. That allows me to find the center of this hole. That's this pivot point. Allows me to find that off the end of the frame. And then because all of the holes are symmetrical, I want the bolt that goes through the roller to be the same height as the bolt that makes the pivot over here. So by using this roller, I can roll it back here, mark the height, figure out the height, figure out my distance off of that back piece of steel. That gives me my pivot point. Eventually, I'll add a smaller flat piece that sits down in here and has a hole in it so that that arm is going to have a bracket on either side to hold that axle to give it more strength. That would be as opposed to running like a piece of all thread through. The problem is the all thread will have some flex. This is a little bit skinny for that, and using the threads for a bearing point is not ideal. Using these bolts that have a smooth shank and then threads at the end, if I use that, when it goes through here, it means that when everything's pivoting on this, it's pivoting on that smooth metal. It's also the thickest part of the bolt, which is stronger than the threaded part because there's more material there. Once I get my pivot point located, then I need this roller. When I lift this up, if I raise this, it comes up. There's nothing holding this down to the table. So my goal is to cut a slot in the side of this table, let the bolt that goes through the axle, and just like this one, we'll do the same thing in the top. That bolt will go all the way through the frame, and there'll be a slot that covers the distance that this has to travel in and out. That way, you can't lift the top off of the roller here, and you can't lift the roller off of the base here. That way, the whole thing is held together, even though it's still allowed to move in and out. Once that's finished, or maybe before that's finished, I have to figure out where this jack is going to mount. This jack, because this is up in the air, the jack can be mounted lower. That helps because I'm going to be pushing against a crossbar that will be located somewhere down here in this lower half. The reason for that is, as I found out on my pattern over here, when I set up my plywood jig, I need to have this jack pushed away from the frame. I think it was about 5 inches or so, but I have 5 inches of travel on this jack. So that means wherever I push against, when it moves up and when it moves back down, that distance from the pivot point can only change 5 inches. So that's where this mechanism gets a little bit more complicated. I'm going to have to make something for the top of this, some kind of sleeve that will sit over the top, and probably that will probably have saddle joint and a T, so that I'm pushing against something and then that can pivot. So as this is going up and down, I've got some play in that armature right here. So I have to figure out this mechanism, the pivot, the cap. This is going to get a base on it that will extend it out and have 2 pivot points that will mount to a bracket welded to this side of the frame. And then I have to make another mechanism that's going to modify this motion, because right now the jack would move this way to activate the jack, or I'm sorry, the handle would move this way. What I want to do is translate that motion into an up and down for a foot pedal over here. So there's another process. These are all the processes of problem solving that we're going through to get this project done. You can see it's complicated. There are a lot of working parts. If we break it down into its smaller components, we can attack one thing at a time. And by putting this together and having a temporary fitment, I can see things like the bolt here. The head sticks out. As you can see here, that head is sticking out, but I want this flat to be up against the frame. So it's okay when I'm up here, but when I go all the way down, that bolt starts to hit. So my plan is, there are different ways to remedy that. I can recess the bolt head, I could countersink it, I could thread one side and run the bolts in from the other side. The simplest way to do this is to cut a notch out, and because this is 3 inches tall, I think this is overkill for what I am doing. So I'm not concerned about the strength being weakened by that notch. I'm going to go through these things one piece at a time. I'm going to get some footage of the individual parts. I'm not going to break down things like welding this frame together, because that's sort of a basic welding skill, and the last person you need to learn how to weld from is me. If you want to look at welding videos, there are plenty out there. I like to watch Jody Collier on welding tips and tricks. He's concise, has real good, clear videos. You can see the details. He breaks it down into its components. He talks about testing the welds for structural integrity. I don't know if he'd be very proud of my welds, but they're strong enough to hold. They're okay for the application. So I'm going to keep putting this together. I hope you can stick with me through this series of videos because it's going to be a long process. There are a lot of steps, but when it's all said and done, I think this is going to be a worthwhile product to have. I think it's going to help me out in the shop, and it's just going to be fun to have something that I built that I can use all the time. So hope you enjoyed it. Keep watching, and as always, like and subscribe. Take care.